All right, let's dive in. We're going to go beyond the chatbots that, let's be honest, we're all using every day. And we're going to explore what feels like the next giant leap for AI, agent systems.
So we've all seen AI that can draft an email for us or spit out a chunk of code. And that's amazing, right? But here's the real question. What if it could actually do the work for you? I mean, not just write about it, but actually handle complex, multi-step tasks from the beginning all the way to the end. Well, that's the exact problem AI agents are being built to solve.
Okay, so here's our game plan. We're going to start with why current language models have their limits. Then, we'll nail down what an AI agent actually is. We'll peek inside its mind to see how it thinks, check out some mind-blowing examples of agents at work, and then we'll tackle the really big one. How do we make these things reliable and safe? First up, the limits of language. This is really about the jump from just having a conversation with an AI to having it take real, meaningful action in the world.
You can think of it like this. Large language models, or LLMs, are absolutely brilliant text generators. You ask a question, you get a great answer. But real life, real work, it's rarely just one and done, right? Most tasks involve digging for information, using different apps or tools, and stringing together a whole series of steps.
And this quote from Bin Hu just hits the nail on the head. An agent is not only a generator of text, it is a controller that translates intent into procedures carried out in the world. So, in other words, it's not a writer, it's a worker. That's the key shift. So if an agent is a worker, what are we actually talking about here? Let's get into our second section, what is an AI agent, or the rise of the digital worker. So what is an AI agent really? Well, it's a system that takes a foundation model, like the LLM brain inside a chatbot, and then it surrounds it with a whole crew of other really important capabilities. Things like reasoning, planning, memory, and, this is absolutely crucial, the ability to use tools.
This diagram here really lays out the whole ecosystem. If you look down at the bottom half, you'll see what are called the enabling technology trends, stuff like foundation models and tool calling. Those are the basic building blocks. And then, across the top, you can see the big challenges these agents are being designed to solve, like automating workflows or dealing with security pressures.
Let's just quickly break down that foundation. It all starts with a powerful foundation model, like a GPT-4 that acts as the brain. Then you add tool calling, which is what lets the AI use other applications or run code. You need some kind of reasoning and acting orchestration to manage the whole plan, you need memory to keep track of what it's done, and you even need multimodal perception so I can actually see and understand things like images or buttons on a screen. Okay, so let's get a little more technical and peek under the hood. Section 3, inside the agent's mind. We're going to look at the core operating loop that really makes these things tick. This diagram right here is the key to how an agent thinks. See, right there in the middle, you've got the LLM, the brain. But notice, it's not just sitting there by itself. It's inside this constant feedback loop that involves 4 critical functions: perception, planning, action, and memory. Let's walk through that loop right now. So let's break that loop down. First, you've got perception. The agent looks at its environment and takes in new information. Second, planning. It thinks about that info and comes up with a step-by-step plan. Third, action. It actually carries out that plan by using its tools. And finally, memory. It updates what it knows based on what happened, so it's constantly learning. And then, the whole cycle just repeats itself. And this isn't just some abstract theory either. This is the practical engineering process. First, you build and integrate the agent with all the tools it needs. Then, you deploy and operate it in the real world. And then, and this part never stops, you constantly evaluate how it's doing and iterate to make it better. It's a continuous cycle of improvement. So we know how they think, but what can they actually do? Let's get to the fun part. Section 4, Agents at Work. Let's take a little tour of what's coming. This is where it gets really exciting. You have these generalist agents that are designed to be, well, jacks of all trades. Using a single core brain, they can pivot to tackle a huge variety of tasks. I mean, everything from debugging code and browsing the web to analyzing data and running these super complex workflows. It's like one brain, many, many different jobs. And this slide is just a perfect illustration of how agents can bring order to chaos. On the left, you see the typical enterprise setup, a total mess of fragmented systems and security risks. The agent then acts as this transformation layer, cutting through all that complexity to produce the clean, secure, and auditable workflows you see on the right. It's pretty incredible. And we're not just talking about the digital world. In robotics, agents are creating this amazing partnership.
You have a high-level LLM that acts as the planner. It figures out the sequence of skills you need to, say, assemble something. And then you have specialized controllers that take over to handle the super precise, real-time physical movements, making sure everything gets done safely.
Okay, so giving an AI control over company data or a physical robot is obviously incredibly powerful, but it also creates some enormous challenges. And that brings us to our final section, making agents reliable and safe and the core trade-offs that come with that.
This diagram really gets to the heart of the problem. Building a good agent isn't just about making it smart. It's a systems optimization problem. As you can see from these scales, developers are in this constant juggling act, balancing three competing forces: reliability, latency, and cost. If you push down on one, another one almost always goes up. And that balancing act creates these fundamental tensions. For example, how much autonomy do you give an agent to work on its own versus how much controllability do you need to maintain? And then there's the huge gap between capability, what an agent can do in a perfect world, and reliability, what it consistently does correctly and safely out in the real world.
All this means that researchers are tackling some absolutely massive hurdles. Things like compounding errors, where one tiny mistake early on can snowball into a complete failure. There are huge safety risks when you give an AI access to real tools. There's the fact that these models are non-deterministic, meaning they're unpredictable, which makes them a nightmare to debug. And a final huge challenge: how do you even measure if they're doing a good job? So look, if you take just one thing away from all this, let it be this. AI agents are not just smarter chatbots. They are complete, complex systems designed from the ground up to perceive, to plan, and to act in both the digital and the physical worlds.
Which of course leaves us with one last pretty provocative thought. As these incredibly powerful systems continue to get better and better, are we just building better assistants to help us with our work? Or are we starting to build our digital successors?